The first lecture is on Vas theory. There are three ways of learning to read the word, and I'll take the word magnet as an example. The first way is phonics. Now, phonics requires you to know the sounds, so you know the m sound. You know how to blend sounds together, m and a and g make mag, and you know how to chunk syllables together, mag and net make magnet. The second way is to make a guess based on other words in the sentence. For example, if you had a sentence that said that the magnet attracted iron filings and you couldn't read the word magnet, if you could guess from the words attracted iron filings and ask yourself, what is it that attracts iron filings? Oh yes, magnets do that. You can guess the word magnet from the meaning of other words. The problem is, of course, if you can't read the word magnet, you probably can't read the word attracted or iron or filings as either. And it only works, in any case, in about one sentence in 8. The third way of learning to read is by guessing whole words. And this is our area of research. We'll be spending some time in this field because it's important that you understand the nature of whole word guessing. Originally, our work was not in reading at all. We were looking at newspapers, we were looking at drivers. We wanted to know, for example, when a driver who was experienced came into a corner, what did he look at? And how did that differ to a novice driver? Whereabouts in the road did they look? But eventually we turned our attention to line drawings, such as the one I'm showing you here. The line drawings showed that people's attention is attracted to the parts where the image is surrounded by space. In this case, with the house, the end of the eaves stick out into space. The chimney sticks up into space. And we also found that where contours change, such as the corners of doors and windows, they attracted attention. And the lines I've put here show the way the eyes moved over this particular kind of picture. But eventually we turned our attention to words. And we found that for some children, but not all, for some children, they were processing words like pictures. They were processing the letters that were adjacent to spaces, like the M and the T in magnet, because they've got spaces at the end. The G and the T are also high visibility letters because the G and the T have tails, one that sticks down, the other one that sticks up into surrounding space. So these are what we call high visibility letters. The process of whole word recognition is as follows. First of all, you pay attention to the high visibility letters, the M, the G and the T. The second stage is you then try to match that MGT pattern to another word that you already know, that's already held in memory. The question is, how many words would you know that would fit that pattern? Let's give you an example. If you could only hold one in memory, and this was the way you were processing as a whole word guess, that could be measles, mat, milk, magnet, mother, mist, map, mumps. There are 400 words it could possibly be. Guessing at this kind of level is inaccurate. Remember I said the two end letters would attract attention, but that could still be magnet or midget or magnet or maggot or meat or moat or must or meat. There's still too many words it could be. There are about 40 words that would fit that pattern. But when you get down to 3, that could only be magnet, midget or maggot. So what we call Vas level 3 is the minimum level for whole word processing. If you can process 4, there could only be 2 words that will fit that, magnet and maggot. If you can process level 5, there's only 1 word that would fit that pattern. So the accuracy of your guessing depends on the number of elements that are being processed in memory. This is called visual attention span. And we'll call it VAS, the acronym for simplicity from now on. This is the VAS level. VAS develops like age, like height. And there's not much you can do by trying to accelerate VAS levels by training. You have to teach in consideration of what their current VAS level is. So you therefore need to know each child's VAS level before you teach whole word processing. That's absolutely important. You therefore need to know each child's VAS level before you teach whole word processing. Because if you encourage whole word processing in a child with a low VAS level memory, they will fail because they're processing the M and the T, the two end letters, in words like magnet, and there are 40 possible matches. If you persist, they may then develop end letter dependence and mid-word inattention. So even though their VAS level may have climbed and be at level 3, they may by that stage be processing just 2 letters and are habituated to doing it. So whole word processing needs at least level 3 VAS. Phonics does not need a high VAS level. Phonics involves processing sounds and blending sounds and syllables together. So if you have a low VAS child, you must teach phonics. And this is the conclusion also reached by 3 international inquiries in recent years in America and in Britain and in Australia, that a phonics-first approach produces the best outcomes. Vas theory explains the science behind those conclusions. And in case you're thinking that we're dealing with small numbers of children, here are graphs of the number of children, the percentage of children, this is in a study of about 3,000 children, the number of children who do not have VAS level 3. The green bar are the failing readers, the blue bar are the average readers. If you want to look at the superior readers, you go to our website and all the data is there, or in the book that we wrote on the subject, Reading Through Tears, all of this data is included in that book. But I want to draw your attention to the child who's age 6. The green bar, you can see, extends almost to 80%. In other words, almost 80% of children at the age of 6 do not have sufficient memory for whole word processing. Even average children, we're looking at about 55%. This is the blue bar at the age of 6. About 55% of children, those do not have enough memory either. Go to the age of 8, along the bottom line there. Look at the green bar. You can see at the age of 8, about 30% of children still have not got VAS level 3, the minimum level for whole word processing. Whole word language has been encouraging teachers to teach whole word processing to children right from the word go. This is the flaw. This is the serious flaw in whole language. I said that if you teach whole word processing to children who have low VAS, that they will tend to depend on end letters. This is a child who looks at a word like net and misguesses it as not or nut. This is the signature of a child who is habituated to using end letters. They develop inattention to the middle of words. If you look at these green bars, look at the age of 11. About 70% of failing readers are still repeatedly making errors in the middle of words with 3-letter words. I'll repeat that, 3-letter words. Frequent errors. Even the average children are also making these kind of errors. Whole language promised that we would grow out of these problems. These figures deny that. If you look at the age of 14, you can see that over 50% of children aged 14 who are failing are still using end letters and making mistakes in the middle of 3-letter words like net. We peer reviewed our work in Australia and also in Britain. And what you see here is some comments by Dr. Susan Moore, a respected research editor of the Education Monitor, who saw the importance of what we were doing. In Britain, we submitted our work to one of the leading psychologists in Britain, Martin Turner. Martin Turner described our work as the most exciting development in literacy in a decade. And if you think you've now understood Vas theory and Vas feeling and the interaction between Vas and phonics, consider applying for testing and registration as a Vas certified tester. We will nurse you through the procedure.